Special angles notes. Special angles formed by parallel lines. Parallel lines never intersect. They could go horizontally, they could go vertically, they could even go on any diagonal, but they are always the same distance apart and will never ever touch or intersect. If you look at this diagram where we have parallel lines that are horizontal, there is a transversal line that goes through it, and we'll talk about that later. But the important thing to know is that the parallel lines, when you look at these three lines, are the two that never ever intersect. Perpendicular lines are lines that intersect at right angles. They make 90 degrees, so you would tell that with a box. On the left-hand side, we have two lines that are perpendicular and intersect at 90-degree or right angles. On the right-hand side, there are two segments that are perpendicular because they intersect at 90 degrees. The transversal line is the line that intersects parallel lines. So it's the line that goes through the two lines that are parallel or never meet. So in red, you have the parallel lines, and then in blue is the transversal. Over on the other side, in the picture on the right, the parallel lines go on the diagonal and they are in red. They never intersect, but the transversal is going horizontally and it intersects the parallel lines. Alternate interior angles are two angles that are on opposite sides of that transversal line, but they're on the inside of the parallel lines. If you look at the picture on the left, you have pink angles, which are C and B. These are examples of alternate interior angles because they are on opposite sides of that intersecting or transversal line, but they are inside the parallel lines. Then you have angles D and A, which are also alternate interior angles because, again, they're on opposite sides of that intersecting transversal line, but they are also inside the parallel lines. If you look at the picture on the right, here's another example. You have X angles, which are alternate interior. They're on the opposite side of that transversal line, but inside the parallel lines. Or you have the Y angles on the right. They are alternate interior angles because they're on opposite side of that transversal line, but inside the parallel lines. Remember that alternate means opposite and interior means inside. So always think that if it's alternate, that it's opposite of that line that's intersecting. And if it's inside the parallel lines. The cool thing about alternate interior angles is that they are equal. So if you know what one measurement is, you will know what the other one is. So if one was 50 degrees, then we know the other's 50 degrees. For alternate exterior angles, these are two angles that are on the opposite side of the transversal as well, but they are on the outside of the parallel lines. On the left, you have angle number 2 and angle number 7 are alternate exterior angles. Pretend that the lines are actually parallel. Angles 2 and 7 are on the opposite side of the transversal line, and they are on the outside of the parallel lines. Same with number 1 and number 8. They are on the opposite sides of the transversal line and on the outside of the parallel lines. You can see it more closely in the picture on the right, where you have the angles X are on the opposite sides of this transversal line and they're on the outside of the parallel lines. And then same with angles Y. These are on opposite sides of the transversal line and on the outside of the parallel lines. Remember that alternate means opposite and external means outside. Another cool thing about alternate exterior angles is they are equal, which means if you know the measurement of one, then you know the measure of the other. So if one is 160 degrees, the other one is 160 degrees. Corresponding angles are two angles on the same side of the transversal, but one angle's on the inside of the parallel lines and the other's on the outside of the parallel lines. You can see that angle D and angle H are on the same side of this transversal line, but one is inside the parallel lines and one is outside. That makes them corresponding angles. You can also see that you have angle A and angle E are on the same side as the transversal, but one is inside the parallel lines and one is outside. So angles A and E are corresponding angles. You also have B and F. They're on the same side of the transversal, but one is inside the parallel lines and one is outside. So B and F are corresponding angles. And finally, you have C and G. They're both on the same side of the transversal. One is inside the parallel lines and one is outside, so those are corresponding angles. In this case, you had 4 sets of corresponding angles. If you want to break them out more, you could look at the picture on the right. You have X is on the same side as the transversal, but one is inside the parallel and one is outside the parallel. Then you have Y, same side, one is inside the parallel lines, one is outside. You have Z, same side of the transversal, one is inside, one is outside. And W, same side again, but one is inside and one is outside. The cool thing about corresponding angles is that they are equal, which means that if you know the measurement of one, you know the measurement of other. So if one was 160 degrees, then the other one's 160 degrees. Vertical angles we've already talked about, but now we're going to look at some more difficult diagrams that include them. Remember that vertical angles are two angles that share a vertex but no sides. We talked about them forming V's and just having one point that they touch at the vertex, like an Eskimo kiss. So in the picture on the left, you have the A angles are vertical angles, and remember that means that they're the same. Then you also have B's that are on the top and the bottom. They also make that V where they only touch at the vertex, and those are vertical angles. So now look at the diagram on the right. This is a little more difficult. Look at where the V's touch their noses. You have 1 and 3 are vertical angles. You also have 2 and 4 are vertical angles. You have 5 and 7 are vertical angles. And finally, 8 and 6 are vertical angles. They all make the V's that point to each other touch only at the vertex, and so they are vertical and equal. The cool thing about vertical angles is that they are equal. So if one is 40 degrees, the other one's 40 degrees. Now let's test your knowledge. Let's see if you can look at the diagram below and find the special pairs of angles. Number 1, alternate interior angles. Remember that alternate means opposite and interior means inside the parallel lines. So whatever we are going to look at has to be inside the parallel lines, and we want to make sure that they're opposite of the transversal. So it could be angles 3 and 6, or it could be angles 4 and 5. Number 2, alternate exterior angles. Remember that alternate means opposite and exterior means outside. So we're looking for outside of the parallel lines and opposite side of the transversal. This could be angles 1 and angles 8, or angles 2 and 7. Corresponding angles. Remember that these are on the same side of the transversal, and one has to be inside the parallel lines and one has to be outside. These could be angles 1 and 5, angles 2 and 6, angles 3 and 7, or angles 4 and 8. Vertical angles. Remember that vertical angles only share the vertex. They make V's that point at each other. These could be angles 1 and 4, angles 5 and 8, angles 2 and 3, or angles 6 and 7.